Okay, so this is our monthly runner architectural discussion. We have a couple topics lined up. Number one is nesting and macOS runners in AWS, the way that we're setting it up for GitLab. We're going to discuss the architecture, see if there's anything that we need to really dig into. And if we finish that, we'll discuss a few proposals that have been floated over the last couple of days around build logs, built-in shell, and metrics and tuning concurrency. So I could introduce the topic real quick. I'll just give a real TLDR summary of what it is that we're talking about here, and then maybe we can drive the discussion with questions and comments. Yeah, so we're going to run Mac. We're going to run our Mac runners on AWS, and we've been building this for some time. We're using the new auto-scaling architecture that puts the instances behind the instance group abstraction, which means our autoscaler, which is called task scaler, uses a plugin, so the plugin interface is cloud agnostic, and we have an AWS specific plugin, which is going to scale up and down an autoscaling group. And it will grab instances from there and allow runner to connect to them. So this is the first production usage of our new auto-scaling architecture. And it's also specifically our, our stable GA level, or will be GA level Mac runners. The interesting thing about this setup is we've done a bunch of additional work on top of the auto-scaling architecture to work around limitations of Mac instances on AWS. In particular, Macs start slow. You have to pay for 24 hours minimum, and there's a scrubbing process as they go away. So what we've done is, since in AWS you get a dedicated host, we drop the job into a VM inside that instance, so that we can throw away the VM. We use the VM as the isolation mechanism. This is different from Linux in GCP. In Linux, we just create and delete VMs. That's our isolation, but they are so easy to come and go that we just delete them at will. The instances, however, in AWS, the Mac instances, we keep around since they're sort of slow to start and stop. And we just do them in containers, not containers, VMs, sorry. And also we're limited to 2 VMs per instance. So we put 2 of them in there. So we have a little bit of infrastructure also to allow more than 1 job per instance, which is a change from the previous limitation, which assumed 1 to 1. So there's the new runner architecture. There's the abstraction of putting jobs inside VMs, VM isolation within an instance, and more than 1 job in a single machine. So this could, you could configure this to do more than 1 job in a machine without VM isolation, if you trust all these jobs. We're multi-tenant on GitLab, so we have to keep that. But so there's a number of interesting, I think, implications that come out of this. So are there any questions about the architecture, comments, or concerns that you have?
Is there another way to have isolation other than a VM within the Mac shared runners, or was that the only choice, really?
Right now it's basically only the VM, but you could consider that you could have a container it's not a security boundary, but you could maybe want to do container isolation. You could have I don't know. That's all I could think of, this. But I think part of the direction that we've been going with this configuration is trying to make the orthogonal aspects of runner configuration usable separately, so that in this n-dimensional space of configuration, we can do different things. Like, you don't want to use auto scaling only with Docker machine, right? So there's the execution environment, shell or local, Docker, Kubernetes. There's isolation, which has a couple mechanisms. There's auto scaling, which is like, how do you manage the infrastructure? They're not all in 100% orthogonal, like Docker kind of shows up on more than one dimension. But generally, we're trying to separate them. So that's one of the reasons why we have VM isolation as its own like tree in the config. Have you seen that? Have you seen the VM isolation configuration?
Not recently.
Okay. Yeah, so what it looks like with the new auto scaling setup is you basically have auto scaler and you give it some parameters like in configuration. And then there's a plugin config where you can plumb a string map through into the HashiCorp Go plugin. This allows you to configure details of the cloud provider all the way down in the concrete plugin that you start from the config without coupling in runner. So runner doesn't have to know what all the configurations are for this. So you could configure things like machine types or like weird cloud specific stuff without touching runner. So there's the connector config that in there underneath autoscaler, and there's also outside the plugin config, and then there's also connector config, because you need to know a little bit about once you do choose a machine, how do you connect to it? Use WinSH or Win something or other, which I've never used, or SSH, which IP address, internal, external, the key, those sorts of things. So those get plumbed through to the connector. And then there's the isolation aspects of it. So if you look into, I think it's the provider in the internal executors, internal autoscaler, provider.go, you'll see in the prepare function, it sort of like starts at a point, and then if there's no VM isolation, then it just returns a connection directly to the machine. If there is, then our code's it's a little bit all over the place, but there's a place somewhere, I can't remember where, but there's a place where it actually connects to the machine. Then it uses that connection to talk to a daemon, which is running on the instance itself. It's a little server. It's like a little control plane just for that instance, and says, okay, now make me a VM. And so it makes a VM, and then what it does is it opens another tunnel inside the connection to the VM created for the job, and then returns that. So there's sort of like the isolation is abstracted a little bit, so that like in a way you just get back a connection and you don't really know if it's tunnel or not. It doesn't really matter. So we're trying to tease some of these parts apart. Does that answer your question? I got signed out of Google for some reason, so I have to sign back in to take notes. If there's anything that I said that is new or interesting, would you take a note? And maybe we'll give it just a minute for you to think about it. And if there's nothing else, then we can move on to the next topic. There we go. Yeah, I can't speak and type at the same time. I struggle to even speak and think at the same time. So I'm not a very good note taker. I'm just not. Sorry. Cool. All right. Well, I kind of feel like if there's more questions that come up during this, and there's a break, we can bring them up, or we can discuss them on chat, or feel free to ask additional questions in this doc. And you can ask me a question by highlighting your question and assigning me like a comment, and then mention me and check the box to say assign it to me, and I'll get an email saying I have something to do, and I'll come and answer the question, and then go from there. So if you're watching this async, you can continue the conversation in the doc. It would be nice to sort of keep everything there. So all right, so that kind of is that for nesting and Mac runners. Okay, summary by Joe. All right, let's discuss the next proposal to improve build logs. I was wondering, Aaron, if you could introduce this idea. Oh, Aaron, where'd you go? Oh, man. Aaron, are you able to give us a TLDR of your proposal to improve build logs 38.620?
Yes, 1 second. Everything just sort of crashed and I had to log back in.
Okay.
Yeah, give me a minute.
Okay. All right. Actually, let me take a moment, and we'll give Aaron a sec to get himself situated, and I'll just mention the concurrency tuning idea. So the idea is this, okay? We have runner, which is in sort of like a central location where it has access to all the physical resources we're actually running the job, and it's communicating with GitLab. It's able to tell you how many jobs are running and what percentage of the configured concurrency that is. I could describe it as concurrency utilization. And concurrency, so there's a couple terms here, because there's a couple different ways of setting this up. If you have a runner that is just executing jobs locally, concurrency limits the number of jobs that will run on that machine. If you're in an auto-scaling scenario, concurrency limits how many jobs that runner in pure manager mode will route to other machines. And what limits, or what configures how many jobs run on those individual worker machines or ephemeral machines, is the capacity per instance configuration. This is a new configuration. This is the one that we added for Mac, so, and we set it to 2. So my observation is the concurrency setting and the actual physical resources of the machine are disconnected in a way. So like you have to choose, and you have to carefully choose them. A very minimum bar for like what users will probably want is to be able to see what those are over time. And I think we're working towards that. We're going to have like, a first-class runners page. Gina has been working on like a bunch of, different fleet management like pages that, and part of that would be really nice. I'm just sort of imagining being an operator. It would be really nice as an operator to be able to see the like resource utilization of my machines along with the concurrency utilization. And then I would be able to do something like say, I could really pack more jobs into this machine, or I noticed that I keep hitting like a CPU threshold. I would get more performance by reducing concurrency or capacity per instance in an auto scaling scenario. Nobody's using that yet, but this is a future idea. So there is like a desire, there is like a legitimate need for some high quality metrics pipeline. Knowing that, there's also like the runner itself is both the provider of the metrics and the actuator. So there's a chance to do a little bit of experimentation here. And we could actually have the runner look locally and say, hey, I think you should set your concurrency to this. Like it has all the data there. It's because it's all in one process, all in one machine. You know, it can do some it would do some interesting experiments with really without doing a lot of plumbing. And this could look like either recommending a concurrency, it could actuate it. You could just tell it, just pick what you think is the right value. There's also like another safety mechanism we could do if runner is aware that a machine is maxed out, it can actually artificially reduce its concurrency and stop accepting jobs until it has more. So like imagine like a runner that processes a wide variety of jobs, little tiny ones and giant huge ones, right? If a runner picks up a huge job, it's going to be pretty busy. And it really should let somebody else pick up more work. So it would be a way to exhibit back pressure on the system because it has no internal queue. It can just stop taking jobs from GitLab and they'll go to other runners. Another interesting thing about this is, what was I going to say? I wrote all this down, so I didn't have to keep it all in my memory. Yeah, so there's the idea of tuning concurrency, but also sort of finding a way to take incremental steps towards a good architecture where we can easily get the metrics where they need to be. Like it'd be nice to be able to provide these to the user just so they can see what's going on and trust additional automation that we make. Tomasz.
Do you want to finish? Because I can wait with what I have to say. If you want to say anything more about the proposal.
That's okay. I think you can. There's a lot more details in the proposal, but good. You can read it yourself. I'm interested to hear what you want to say now.
Okay, so I will play a little devil's advocate role here because I see several problems with what you're proposing already.
Okay, go ahead.
Yeah, first thing is that we are mixing two things here. One thing is being able to provide metrics to the user and show some internal behavior of runner in a good way. Today we can do that only if the user setups Prometheus, starts tracking the metrics, setups Grafana or anything else to draw that. So it's not easy for someone who haven't done that in the past. And being able to provide some basic metrics of what's happening with the runner, it's totally a thing that we should have, and I'm full into that. The second thing is using metrics to control what's happening with the runner, and here we are hitting several problems. First one is that concurrency is not only about the resources that you have for the job. It's about many other things that you need to consider. Like, for example, what resources the runner manager has. Because every job that we handle, the runner process itself needs to do things for that. We are handling log buffering, we are handling masking things in the log, we keep local resources in memory needed for the runner manager to be able to execute the job and bring back the information. So we need not only think about where the job is running. This is in the case of the distributed auto-scaling scenario, like on our SaaS runners. We need to think about this and about the runner manager itself. So we already have two different places to track. It's also not only about the resources like CPU or memory or disk. For example, in our case, with auto-scaling, we also need to think about what quotas in GCP or what quotas in AWS we have, whether we are able to scale up or down. So auto-tuning, it's not a trivial concept here. It's a very, very complicated concept. And I would be very careful with setting any auto-tuning like that. The next problem is if we should change anything automatically. I would say no, or at least it should be an opt-in, because it should be never a surprise for a runner administrator that you're starting getting errors because of, I don't know, exceeded GCP quotas. And after investigation, you find out that your runner automatically scaled from, let's say, 1,200 concurrent that we have right now to 25 million, because some calculation made it think that it will be able to handle that. So if we would want to have auto-tuning, it would need to be opt-in, no matter how sure we are it will be working, because it should be always the owner of the runner who decides whether it's okay to do that or not. And the last problem I see is that runner will, like, to track resource usage, we need to get that information in some way. How to do that? How to do that in a good abstract way that we will not like pick all of the Prometheus code into the runner itself. Because if runner will need to find out what different resources the job environment uses and track that, we need to have a way to gather that information. It needs to support all of the different environments that we are using, so different OSs, different architectures, different distributions, even in Linux operating system. Like if you look on Debian versus Red Hat, some things like how to gather CPU usage will already differ. And if you want to add FreeBSD, NetBSD, Darwin, OS X, etc. to that, we are bringing to the runner a lot of things that runner shouldn't be responsible for. So there are multiple things here that for me create a warning red light that we may be doing something that should be not a responsibility of the runner. Okay. And if we want to go in that direction, we need to find out what we can reuse, how we can integrate with what we already are using, and whether it even makes sense.
Okay. Yeah, I'd like to take a few minutes and address systematically your concerns, starting with number 2, and then number 3, and then number 1. About rolling this out safely, anything automatic. Any automation needs to be done with user trust. Like really, the user needs to be able to understand what you're doing or what you intend to do. So like a minimum starting point for rolling out any automation will be to show the metrics that we're looking at, right? And then when we think we know what to do, to just show that on the metrics as well before we actuate anything. And then allow the user to opt into it before we make it a default. So it is definitely, like, I 100% agree with your point about not jumping into throwing automation in that's on by default. And I think, and there's a process of rolling out that kind of automation. So I don't mean to gloss over it. This is just the high level idea. There would be a whole process for rolling that out. So I totally agree with your second point. On the third point about how to get these metrics without coupling runner to every environment, we have a good start with the abstraction we've done for the auto-scaling system. We actually have 2 interfaces in there. One is the fleeting like instance group interface, and we also have the connector interface. So if we want to get metrics from, so there's two separate situations we should talk about, auto-scaled and not. So we'll start with auto-scaled. If we want to get metrics through fleeting or through an interface that's abstracted by cloud provider plugins, then we just define a common resource-oriented API. And okay, excellent. With regard to resources like quota that are like not physical resources, but other limitations, in designing this, there's sort of a high-level design. There's all the details are left out. One of the details which I have in the back of my mind would be to treat resources in a very generic way, so that the plugin itself can surface a resource, which is quota. It could be like, hey, here's CPU, here's memory, here's quota. And so that the runner can make its decisions based on not exceeding any of those resource limitations. So I think quota actually fits into this idea, and it can be done in a generic way, as long as we don't start hard coding provider specific concepts into runner. I'm 100% in agreement that we should be very careful about how much runner is responsible for, and all of its responsibilities should be logical and generic. With regard to, so like in a non-auto-scaled scenario, those metrics should come from, they should be abstracted away as well in some mechanism. Like you should be able to provide metrics for different operating systems without coding in runner. Your first point was about so you were mentioning that like getting metrics into the UI is something makes sense to you with regard to tuning concurrency and the kinds of concerns that runner has. Oh, the important part of your first devil's advocate volley was that runner does more than just run the jobs. It also has this whole overhead of orchestrating the jobs, getting them, keeping track of them, streaming back the logs, etc. So again, let's break this into the two scenarios. In an auto-scaled scenario, there's a section in this proposal called Tuning Runner Manager Concurrency, where I discuss like the same tuning mechanism, whether it's advisory or whether it's just metrics or whatever, can be applied to the job on the ephemeral VM, and it can, which will be recommending something for capacity per instance, and it can be applied to the runner manager itself, which will be tuning concurrency. And that would give you an indication about like how many, we're talking about how many jobs a manager can manage. That's all that overhead. On the other hand, when it's all in one machine, it doesn't really matter, because like there's overhead for each job, right? And that overhead is like some management and some execution. But if I observe that when I'm running at 50% concurrency utilization, I'm also running at 50% CPU utilization, then things seem okay, right? Maybe some of that CPU is management, some of it is execution. It doesn't really matter to me. I just take a look at, and I'm just going to look at that graph of like concurrency utilization to resource utilization. And it will be sometimes linear, and sometimes it'll sort of curve up, you know, as you get less efficient with more towards the edge of your capacity. So I feel like your concerns are the same ones that I have that I want to avoid. So I'm glad that you voiced those. I think that it's still worth digging into the metrics part of this. I was just looking for like a way to sort of take a little stab at getting a metrics pipeline going that's higher quality.
Yeah, like
That's
I'm not against doing that. Like if we've been talking about the similar things for a very long time, including things like provide basic metrics on the runner page so that we can see what concurrency or limit utilization we have right now. Because currently you don't have that information at all, unless you set up Prometheus and know how to query it to find that concurrency. And this is where the runner produces the metrics. So what we export as a Prometheus metric for Prometheus, we could at the same time send to GitLab and start providing it. So we totally.
Or we could ask GitLab to get it from Prometheus, right?
For example, but again, then you need to set up Prometheus. Then you need to know how to do that. For some users, it's not easy. For users like GitLab.com. For self-hosted runners, you would need to allow GitLab to access your self-hosted Prometheus to query it. Not everyone will be okay with that. And at the same time, the internal data about what's happening with the runner we are exporting that for Prometheus to scrape it. We can as well send it with the API to GitLab.
Okay.
So that
Sure.
so that GitLab can show it on the page and show you, okay, at this moment you're at 20% of your concurrency utilization. You're at 98% of your limit utilization. All that data that runner has internally, we can do anything what we want. I'm pointing the external resources that we would need to track. This is something that needs to be done with caution, because you just not couple runner too much with the mechanism that can be used to provide that information. And a separate thing is that concurrency setting is not as simple as looking on CPU utilization or looking on memory utilization. There are multiple factors that you as the runner owner need to take into account and decide what you can set as a concurrent, what you can set as the auto-scaling values, what you can set as basically any other setting that we have in the runner. So like the idea of being able to detect something and propose user how they could adjust their configuration, it's a very neat idea. But when you start doing that, you find out that it's not an easy task. The way how we got to the current settings of our SaaS runners, for example, why we have the concurrent setting that we have, why we have the auto scaling settings for Docker machine in the way that we have that, it took us a long time of playing with that, understanding what resources we need to look on, what resources we can ignore, and then make a decision what settings is the best one. And this will differ for every scenario, for every executor that you use, for every type of jobs that you use. So I just want to highlight that this is not a trivial thing. Not as trivial as let's compare concurrency utilization to basic resource utilization and make decision about that, because it will not work in many scenarios. But I'm fully into experimenting with that and checking what we can do to get there.
I hear you about the complexity of the configuration space. And actually you gave a very good and detailed explanation in chat, which I captured in an issue. It's linked at the top of this proposal under the words configuring runner concurrency. And I think a good start would be definitely to document that as much as we know. I mean, maybe this is enough just to capture it here. So yeah, I know that there's a lot of complexity there. Part of what my goal here is to start playing with it a little bit. Find a way just to sort of dip our toes in the water. And what seemed to me like a good starting point was the idea of the auto clamp. That is, if runner knows that there's going to be a problem, then slow down. In other words, if runner is at like 95% of its memory utilization and only 50% of its concurrency utilization, it's kind of a no-brainer that it needs to slow down and stop. And if we were to implement that as a spike, I think that we would learn and have a chance to dialogue more about how you get metrics, about what it looks like, what the interfaces are, like how you keep track of these things. It doesn't even have to be something that we necessarily roll out, or if we do roll it out, it could start as an advisory, like a warning, be like, hey, by the way, you're about to go out of memory, and just see what people think of it, you know, like a first iteration. I kind of feel like we need to write some code. We just need to play around with it in some way to start getting this set up. We all know that we want the metrics. So something that actually starts collecting metrics. And I feel like the fleeting interface approach is a good one, because like it's abstract, you know, like if we can collect metrics from fleeting. But The other reason why I like the idea of the auto clamp spike was it didn't involve plumbing the metrics back to runner, or sorry, plumbing the metrics back to GitLab, because as soon as you go between two systems, it actually makes things a lot more complicated. We'll have to go there, right? Users are going to want to see this. We need to decide how to get those metrics there. But it'd be a lot easier if we could say, hey, look, I have these metrics right here in this format that's just beautiful and ready for you to consume. I'm even doing this really interesting thing you should tell the users about. You know, where can I put these metrics? You know, like, but right now it's still just theoretical. So yeah, that's my thoughts. Aaron.
I thought about metric collection a while ago, but more to do with from the job perspective. So I figured it could be added to fleeting. You'd want that collection there because someone's job might be using the whole instance, or you might have multiple jobs on it, but you want to get that data back. And then also, like, at most sort of isolation levels, there's usually some way you can run stats. I think Kubernetes allows you to do it for a pod. Docker allows you to do it. Most hypervisors allow you to do it. Unfortunately, on macOS one, I don't think does, but Parallels did. QEMU, Cloud Hypervisor, they all have some way to get the statistics back, and it could be for the job that you're running. And adding those interfaces would be a great step, I think. And I was just going to feed it back in to the job log. Like every 5 seconds or so, you just feed it in, and it could be hidden from view. And this is like goes on to my semantic login idea later on. Okay. That the job log, it hides all this data, but when you render the job log back, not only does it give you the timestamp, which is a really nice feature, but it will tell you what the CPU and RAM and like disk usage was at that point in time. Then we could feed that back into suggesting that they need a larger instance for that job, or they don't need an instance of that size.
What point would it come into the job log? Would that be from the ephemeral VM, or would runner merge it into the job log after getting it out of band?
See, I think runner would have to merge it in. So this is kind of moving on slightly, but it's kind of relevant.
That's okay. Yeah.
So on the build logs idea, like the last step to it is to add semantic login, and some of that is like. So the sort of our semantics at the moment, like we can do a section in the job log, which adds a timestamp, and then we've got like ANSI colors. So we show like warnings and errors with just colors, which isn't great. It should ideally sort of be tagged that this is an error, this is something else, this is a section, this is grouped information because it's relevant to just this area of execution at this build stage. But one of them would be adding a semantic tag where it's like, this is the CPU and memory usage at this point in time. You wouldn't see it when you render the log, but the renderer would pick that up and it could graph it to the right-hand side in like some panel. And then it could collect the average and afterwards be like, you know, the average and maximum and suggest that, you know, this job was capped here at 100% CPU usage most of the time. So you might want to use a bigger instance, or it hardly used any CPU. So we could,
you know, if it's the runner that merges this into the job log, that totally fits, right? The important part is that runner will be in some abstract way collecting all this information, it'll have some interface, and you can route that wherever you want to. You can put it in the job logs, put it in Prometheus, put it in directly into GitLab. So
yeah, so I agree. Cool. We'll have there's like multiple uses of some interface where we're collecting statistics. And a lot of the time we don't have to mess with how we do it on Debian, how we do it on, Arch Linux, because Docker, Kubernetes, the VM layer provide it for us. And that's probably good enough to get going. That might be all we ever need. We only worry about it at like the isolation level. And some jobs just simply don't support it. Or you need to maybe we'll have a binary that sits in the job, like we do with the helper thing, that tries to is an abstraction to, a bunch of different operating systems' way of collecting statistics.
Yeah. And we can degrade gracefully. Like you can always expect that sometimes your metric stream won't work for your setup, and we won't rely on that. It'll just be, we'll degrade gracefully.
So yeah, I think it's needed anyway. I don't know. It does sound difficult to do the concurrent tuning, especially like the per instance scaling. I think that I've only briefly looked at your proposal, but the capacity per instance, like at the moment, it's fixed size, and everyone can know. Everyone knows that when they choose a tag that gives them a runner, the size of they know the capacity of the job that they can put there. If that's scaling, like one instance then allows 3 jobs and someone changes their script and it ends up using more CPU all of a sudden, they won't have as much headroom anymore.
Yeah. Dimash was right. There's a lot of things mixed up in here. It's like, I think the core of it though is really around like getting the high quality metrics.
Yeah, definitely. I think we should be doing that like today.
Right.
Yeah, like 2 things that I heard are a little warning for me. First, let's not forget about shell executor. Not everything is in a VM or in a container. Second thing, that we can put something like helper binary in the job environment. This is what I was saying about not doing things that runner maybe is not responsible for, like creating a binary that will be able to track some metrics for every possible environment that we want to support. Like this is a totally different thing that we all do. There are already tools for that. I'm just not sure if we should be adding another responsibility to ourselves. But
can we talk more about the shell situation? Like, let's just imagine that we are using a shell executor. What I thought would happen would be the runner would collect metrics from the whole machine, all jobs included, right? Like just the whole machine, and pair that with what it knows about concurrency to deduce what the CPU impact of each job is.
Yes, this is clear. The question is how to get these metrics. And Aaron was talking about
Magic.
getting metrics from Kubernetes or from Docker or from virtual machine hypervisor. These are tools that we can query about metrics. They have API that we can fit into. But when we work in a shell executor concept, we don't have a virtual machine hypervisor. We don't have a Kubernetes or container engine. We just work on a local host, whatever it is, wherever it is. We are not aware how it is managed. Is it a container? Is it a virtual machine? Is it a bare metal? So we need to get the metrics in some other way than calling an API of a well-known engine.
Can we use a similar plugin mechanism like we do with fleeting and say, okay, here's our supported plugins and you can write more plugins and we'll, just tell us how you want us to get the metrics.
My guess is that there's already some abstraction for all of this. Like it would surprise me if there wasn't.
Yeah, like if we would not be talking about getting that into the runner, but just how to track resource usage in the job environment, this is something that we already been looking on. And we've been experimenting with Prometheus, and like Prometheus already has a way to get the basic resource metrics. You have Node Exporter for Unix-based platforms. There is Windows something. There is a separate exporter for Windows world. It produces metrics in the Open Metrics standard, and then you can put that into Prometheus. And we've been experimenting with reading metrics from Prometheus with Runner and sending this back as a referee artifacts type. Now, we could go in a similar way, use the existing tooling for getting metrics and fit into their API, or we can write something by ourselves. What I'm saying is try to avoid writing something by ourselves as far as we can. To just not create yet another API, to just not create yet another standard, to just not to not put ourselves in a place where we put ourselves with Docker machine. That now we need to maintain Docker machine because this is a requirement for our executor, but we don't really want to be specialist of what Docker machine does. And the same goes with the metrics. Different platforms, different environments will allow us to read metrics in different ways. And now we can either try to abstract that and look for tools that already exist and are maintained by people who know how to handle that, or we can do that by ourselves. And I just think that doing that by ourselves is just a risky thing, because it will require a lot of time from ourselves. It will just put another thing on our plate, and we already don't have much capacity for handle everything.
I agree completely. Like, the Docker machine situation is difficult. The term that I've been using for this is coupling, like whether or not runner knows and has to support something specifically. I think it might be useful to actually have an architecture page where we describe the things we will and will not couple with. For example, it's actually a very important feature of a runner that the configuration for the fleeting plugin is a string map and plumbed through without any coupling, because it means the runner doesn't have to know anything about what's inside the plugin. We should have a similar kind of approach to whatever we do with metrics. Runner should not know where metrics come from. It should have one type of metric that it deals with, that's defined by an interface that is provided to it by either fleeting plugins or some other system. I think Aaron's and you were both talking about like using something that exists already. If we can attach something that exists already to an interface that is specific to runner, then we can replace what that something is without any coupling. So yes, I mean, everything you said, I agree with 100%. So it's not really, I think one of the, if we start writing some code for this, it'll quickly become clear what's coupled with what. And then we can point at it and say, hey, this is going down that direction we don't want to go. Or actually, I could imagine replacing what's underneath this interface without any trouble. So anyway, thanks for the comments. We only have 7 minutes left, so I don't think we really have enough time for other topics. Is there anything else on this one? It was a really helpful discussion. I appreciate it. Yeah, I renamed the issue to be concurrency tuning / runner metrics, because it's actually kind of a big ball of all that. So yeah, I'll link this portion of our architecture discussion into this issue, because I think it's a really nice sort of conversation about it. And I added some, if you have specific thoughts about each of these different pieces separately, like, for example, how it fits into Kubernetes, I made some topic threads below too. I've seen other people do that. It seems like it works well. So, and if it's okay, Aaron, do you mind if I copy a few of your comments from chat into the issue? You mentioned a few of your concerns on chat, so cool. All right. Well, thank you for that. Anything else before we close? All right. Go team.
Thanks. See you.